Hi, welcome to our video tutorial discussing Kirchhoff's laws, specifically Kirchhoff's current law or KCL and Kirchhoff's voltage law or KVL. Kirchhoff's current law states that the sum of the current entering a node is equal to the sum of the current leaving that node. So for example, we have this node A as seen from the figure. We have current I entering node A, while currents I1, I2, I3, and I4 leaving node A. To form for the KCL equation at node A, we have I, current entering, is equal to the sum of the currents leaving, I1 plus I2 plus I3 plus I4. How about for Kirchhoff's voltage law? Kirchhoff's voltage law states that the algebraic sum of the EMFs and voltage drops in a closed path is zero. For example, we have this simple circuit diagram. What are the steps in forming the KVL equation? First, assume current direction in each resistor. Note, it is alright if you assumed a wrong one because the result will just leave a negative value, but the magnitude would still be the same. Second, choose the loop to form the KVL equation. If the loop passes through a voltage source, there is a rise in potential. Sign of voltage is chosen as the terminal where the loop leaves the source. In our example, for loop X, forming the KVL equation, loop X enters the negative terminal of the voltage source V and leaves the positive terminal. Therefore, the sign for voltage source V is positive. If the loop passes through a resistor, that is a voltage drop or an IR drop, there is a fall in potential. If the loop is in the same direction with the assumed current direction, that is a negative voltage. That's why in our example here, our KVL equation is positive V, it leaves the positive terminal, minus I1 R1, because loop X is in the same direction with I1. Then minus I2 R2, because loop X is also in the same direction with I2. Proceeding with a more complex example, determine VO and I in the circuit shown. First step, assume current direction with each resistor. But there is already a current assumption on the 4 ohm resistor, which is this current I with direction to the right. For the 6 ohm resistor, there is a fall in potential. Wherever the negative sign of the voltage drop is, there points the arrowhead of your current. Therefore, our current direction for the 6 ohm resistor is to the right. Take note also, we have this dependent voltage source VO that depends on the voltage drop across the 6 ohm resistor. Next step, choose the loop. Since there is one loop, let's call this loop X with direction clockwise. This is loop X. Let's make it a default, although you can really choose a counterclockwise loop as long as you follow the rules for the sign of voltages when forming the KVL equation. So let's form the KVL equation. Our loop X passes through first the voltage source 12 volts. As you can see, our loop X enters the negative and leaves the positive. Therefore, that would be a positive 12. No, that's right. KVL at loop X would be a positive 12. Then it passes through this 4 ohm resistor. Loop X is in the same direction with current I. It's towards the right. Therefore, that would be a negative I1 R1. So our I1 is I and our R is 4. Then next, it passes through this voltage source to VO. It enters the positive terminal, then leaves the negative terminal. So this is a minus 2VO. It passes through this 4 volts, enters the negative, leaves the positive. That would be a positive 4. Now, for the 6 ohm resistor, we know that the voltage drop here is VO, right? And as you can see, our loop X enters the negative and then leaves the positive, then that would be a positive VO, which is equal to 0. We don't need to use for the current here because we already know that the voltage drop across your 6 ohm resistor is VO. So this would be our equation 1, but simplifying the equation, we will get for I, transposing the terms with variables to the other side of the equation, for I, then transpose VO to the other side. It would be negative 2VO plus VO, negative VO, then transpose positive VO is equal to 16. That will be our equation 1. What will be our equation 2? Now observe. The current passing through this 4 ohm resistor or the current I is just the same as the current that will pass through this 6 ohm resistor. If you are going to form for the Ohm's law on the 6 ohm resistor, wherein V equals IR and the V of the 6 ohm resistor is VO, let's name this IX. That would be 6IX. But we know that Ix is just or the current passing through this 4 ohm is the same as the current passing through this 6 ohm. If you're going to look at the direction of I, as it passes through the 6 ohm, it's towards the left. I to the right, then downward, then to the left. Therefore, we can say that I is equal to negative Ix, such that VO would be equal to negative 6I. Substituting this equation 2, or we can say that 6I plus VO equals 0. This will be our equation 2. Let's maximize our calculator. Since we have here 2 equations, 2 unknown, solving simultaneous equations using your calculator, we will get I equals and VO equals how much? I equals negative 8 amperes. And VO is equal to 48 volts. Now, as you can see, our I is negative 8. Therefore, this current direction here is a wrongly assumed current direction. It is supposed to be to the left. Okay, so thank you for listening. That's all.